Okay, let's now solve our next sample problem. Nasaan na ba yung ito? Okay. Hi nga pala kay Sedi Agra. Salamat sa aking supportive na barkada sa pag like and sa pag-comment ng fan sign. Ano ba yung fan sign? Hindi ko na alam eh. Shoutout na lang. Okay na yun. Thanks. A right circular cylinder has a fixed height of 6 units. Find the rate of change of its volume with respect to the radius of its base. Okay, so this is the application of a derivative rate of change. Now, let's begin. Mhm. So what are our given? Okay, let V be the volume of cylinder. Okay. Let R be the radius of the cylinder and H height of the cylinder. Okay. So our height is fixed. Our height is constant, 6 units. Okay. So our only variable will be the radius and the volume. So let's solve. So what is our solution? What's the volume class of a cylinder from your Solidman solution? Volume of cylinder is equal to pi r squared times h. Area of the base times the height or the thickness. Now, since our height is constant, we have the volume is equal to 6 pi r squared. Now, remember class from the module 2 that the derivative, that the rate of change is identical to the derivative. So, the rate of change is identical. The derivative is identical to its rate of change. Now, by definition, its mathematical equation is here. The derivative of our function of y with respect to x is equal to the rate of change of y with respect to x. So again, we will need to solve for its derivative. Okay. Now, our step one, let's assign increment. So this would become delta v of 6 pi r plus delta r squared and isolate delta v. So we have delta v equals, let's distribute 6 pi r plus, this is a perfect square polynomial. So let's just expand this one. R squared plus 2r delta r plus delta r squared. Okay. So bracket dapat kasi may parenthesis na tayo sa loob. So this would be 6 pi r squared plus 12 r delta r plus 6 delta r squared. And our v minus v, but our v is equal to 6 pi r squared. So now these two terms will be cancelled out. So our delta v now is equal to 12r delta r plus 6 delta r squared. Next, we divide both expression by delta r. So delta b over delta r now is equal to 12. Oh, sorry. This should be 12. May type pa dito. This should be 12. Oh, sorry. 12 pi. And also dito din, may 12 pi din. So, may 12 Pwede. Yan. 12 pi delta R. So this is 12 pi. So this is 12 pi plus 6 pi delta R. So our derivative, the derivative of V with respect to R is equal to the limit of the ratio of delta V over delta R. So delta R approaches 0. So this is equal to the limit of 12 pi. May nakalimutan tayo book class. May alpha dito. Okay, tama na. Nagmamadali kasi tayo. Okay na. 12R plus 6 pi delta R. Okay. As delta R approaches 0. So from here, we have the derivative of V with respect to R is equal to 12 pi R. Because this term will become 0. So yan na class. Ang ating rate of change with respect to rate of change of the volume with respect to its radius. So you can when our radius is varying, our volume will also be varying. So for a certain number, for a certain value of radius, we can solve or we can find the corresponding rate of change of its volume by substituting the value of R to this derivative. Okay, so that's it. That would be our fundamental concept of the derivative. Now, our next module, we will derive formulas for the derivative of algebraic functions so that we will not use this long solution. This is a very tedious, but it is important class. I want you to be familiarized with this concept before we will proceed to the formulas to be used in differentiation. Okay, so I will, since holidays Thursday, your quiz 1 will be moved next week, and I will just give you a sample problem set 2 on Friday, and also the deadline of your problem set 2, problem set 1 is on Friday. And so I hope you learn something in this video, and please study well. Thank you.